At when to use sine law and then something called the ambiguous case. So we have a rule here, and the law states that sine of some angle divided by the opposite side, so angle A and side A, is equal to sine of another angle B divided by its opposite side, which we would call side B, is also equal to sine of some angle C over its opposite side. So A, B, and C, and I'll show you kind of an example of how to label it, can really be anything. Okay, so whatever we call this angle, we call this A, therefore the opposite side must be A. If this is B, this must be B, and this is C, this must be C. This will solve for things that are non-right angle triangles. So if you notice, I haven't quite drawn anything to scale or anything like that, but this is not a right angle triangle. And you can use sine law to solve it. You can also use sine law to solve right angle triangles. So in primary trig ratios, if you remember, you had SOHCAHTOA, sine, cosine, tan. Those only work on right angle triangles. Even though this is a lot more work than using SOHCAHTOA or anything like that, this will always work. It doesn't matter what kind of triangle it is. So it's a good rule to know. It only works when you have a complete ratio. So when I have, the opposite angle inside, or this opposite angle inside, or this opposite angle inside. If I don't have that relationship, I actually can't use this law at all. So I either have both the reds, both the blues, or both the greens. And then, of course, one other piece of information. It could be this angle, this angle, this side, doesn't matter. But as long as I have at least one set of ratios, doesn't matter which it is, I can use this with the third piece of information. So let's just say these are our pieces of information. So we're going to redraw this triangle, plug stuff in, and we're going to talk about the ambiguous case. And the ambiguous case only happens with sine law, okay? So let's get our triangle. So, as we see above, our angle A is 36 degrees. Our side A is 5.9 meters. And our side B, which is over here, is 7.8 meters. Now I'm going to flip this triangle around so we can kind of make a little more sense of it. Oops, that's not Okay, so let's spin this whole thing around just a little like this. And there's a reason I want to do this. I want to show you how we could technically have built two different cases out of this. So I'll relabel it so that it's right side up. Call this the 36. This is our 36 degrees. This is our 5.9. And this is our 7.8. So it's hard to tell, or we can't tell from the question, whether we're building an acute type of triangle or we're building, oops, that's not the right thing, okay, an obtuse triangle. Okay, this could be the 7.8 and this could be the 5.9. So this is 5.9, this would be our 36 degrees, and this is our 7.8. We don't know which of these triangles we've created. Okay, it's technically ambiguous, so it can be one of the two relationships here. So we're going to try to solve for both of them using sine law. Okay, the first thing we're going to want to do is we're going to look for this unknown angle. We'll call this theta. Okay, and this will be theta also in this one here. So this is going to be the unknown, and it could be two different angles. One of them being acute, which is less than 90, right? We'll say this one is less than 90 degrees, and this one is greater than 90 degrees. So we'll test for both of them and find out the rest of the sides of the triangle. So in the very first one, what we're going to do is we're going to set up the sine law again. We should actually label everything first, like we said. So if I call this angle A, that means this must be side A. Our theta, we can call that B. Okay, that would be angle B, and this would be side B, which means our last one would be C. So we don't have any of that information, so we don't have to worry too much about that. We'll call this side B, and the other one's side A. This is our A, and this is our A. Okay, so in the first one, we'll set up our sine law to try to find this angle, theta, and we'll talk about the acute and the obtuse side of it. So sine 36 divided by 5.9. Changed my marker, didn't I? Yes, I did. Okay, is equal to, so those were both of the A values. Okay, this was an A and this was an A. so we plug that in for the angle A and side A, is equal to sine of theta, theta is our unknown, that's our angle B, divided by our side B, which is 7.8. We don't need the rest of it equal to sine C, that's not important. We only need two sets of ratios, okay? So we have to isolate for theta. So we're going to move 7.8 over. So instead of actually doing any of the calculations, I'm just going to move values to one side. So I have sine 36 divided by 5.9, okay, is equal to sine theta. And when we move 7.8 over, we're going to multiply by it. So we're going to multiply by 7.8. So I'll kind of put that in brackets. And then to get theta, I got to move sine to the other side. Do you recall at all how to move sine to the other side, or if you're looking for an angle, what it becomes when it goes to the other side? Let me move this over.
No.
They use what's called the inverse. So they use sine inverse for looking for angles. Yeah. So when we go to rewrite this, what this will look like is we're going to look for the sine inverse of everything within these brackets, which is the 7.8 times our sine 36 over 5.9, okay, is equal to theta. Okay, so we're going to put all of that into our calculator to try to solve it. So we'll keep that in mind here. And let's kind of jump over. So we were looking for the inverse of, so I should be able to, okay, sine inverse, oh, crashed on, let's try it one more time. No, it's not going to work like that. Okay, no good for us. I got another calculator we can use. We'll use this one. We'll plug all of this in. I wanted to use a nice one, but it didn't work out. So this also stands for sine inverse, or a sine, okay, of 7.8, okay. So I'm going to have that all in brackets, times, and now in this bracket, I'm going to have to put our sine 36, okay, so in those brackets, divided by, and actually going to need an extra set of brackets to put this all in. So sometimes it can be really hard to put this all in one step. That's why it can be very handy to do one piece at a time. So hopefully I've done enough brackets here. Yeah, I think that's right. Answer is 50.99, okay? Assuming I put this all in correct. So what that means is our theta is 50.99, which is roughly 51 degrees. Okay, that makes sense for an acute angle, okay? Now, I know we haven't talked about this too much yet, but in some classes we may have, but there's something called a Caste System, okay? I'll briefly touch on it to why it works with Sine Law. So the Caste System talks about which quadrant the ratios are positive in. So A stands for all. Everything's positive in this quadrant, and that goes from 0 to 90 degrees. That makes a lot of sense. S means sine. So sine is positive in the quadrant from 90 to 180. And that's all we really need to know for this. This is the obtuse idea. So there are two types of angles that would be positive here. In our case, we have one that's 51 degrees. Okay. Then we have another angle, which is 180 minus 51 degrees. So we have to figure out what that is, 180 minus 51 degrees. So 180.
Wait, what would C and T be?
That would be cos and tangent. So they would be positive in those quadrants. But since we're only using sine law, we only have to talk about what's considered quadrant 1 and quadrant 2. Okay. So 129. So what that means is not only can it be an acute angle, but it can be an obtuse angle at 129 degrees. So this is where we get the idea of the ambiguous case. Okay. So we have one angle that's 51, another one that's 129. So this will be our 51 degrees, and in this case we subtract from 180. This will be our 129 degrees. So now this is where we're getting our two different angles, our ambiguous cases, you would call it. To solve the rest of this, it's actually kind of straightforward. The other angle, because we know all triangles add up to 180 degrees, we can add these two together and subtract from 180 to find this. Okay, and the same with this other one here. And then once we have that angle, we would redo sine law again to find that opposite side. So we could use sine law to solve all of this. But what's really important is figuring out when to use our sine law. Okay, and of course in this case, because we had a very specific setup where we were finding an angle where we could have two possibilities, an acute and an obtuse angle.